Hi everyone, in this video we are going to discuss about differentiation rule in algebraic function. So these are the rules in finding the derivative of a function. Okay? So the first one is the constant rule. Okay? So the derivative of a constant, okay? The derivative of a constant is always equal to 0. So example number 1, the derivative of the function f of x is equal to 12. So if we're going to take the derivative of this, f prime of x is equal to 0. Another example, example number 2, y is equal to negative 100. The derivative of this function is y prime is equal to 0. So as simple as that, the derivative of a constant is equal to 0. Next, the power rule. Power rule. Okay, so the derivative of x raised to n. So we have a variable x and having an exponent n. So to find the derivative of this, just simply bring down n, then subtract 1 to the exponent. Okay, so that's the rule. The derivative of x raised to n is equal to bring down n, subtract 1 to the exponent. Example number 3. The given function is y is equal to x squared. Okay, so the derivative of this function is simply y prime, derivative of y, derivative of x squared, bring down 2, then subtract 1 to the exponent. 2 minus 1, that is 1. Instead, we are going to write 1, that is an invisible 1 exponent. Okay? Another example, number 4. F of x is equal to x raised to 4. What is the derivative of this? So f prime of x is equal to, bring down 4, subtract 1 to the exponent, 4 minus 1, that is 3. So the derivative of f of x is equal to x raised to 4 is 4x raised to 3. As simple as that. So that's the power rule. Next, constant multiple rule. Okay? How is it? The derivative of a constant times x raised to n, just simply multiply n to the coefficient. So we have c times n times x raised to n minus 1. Okay? After multiplying the n to the coefficient, subtract 1 also to the exponent. Okay? To n. Example, f of x is equal to 5x. Okay? So if we're going to take the derivative of this, f prime of x is equal to 5. So the exponent of this is 1. Okay? 1 times 5 is 5. Subtract 1 to the exponent, that will become 0. 1 minus 1 is 0. So x raised to 0, that is equivalent to 1. So that's why the derivative of 5x is 5. Another, or in shortcut, just simply remove the x if the exponent of x is 1. Okay, so example number 6. Y is equal to 12x. So the derivative of this is equal to 12. Okay, so another example. Y is equal to negative 5x squared. So the derivative of this, y prime is equal to, multiply the exponent to the coefficient, 2 times negative 5, that is negative 10. Then subtract 1 to the exponent. So 2 minus 1, that is 1. Okay? 8. Example number 8. F of x is equal to 4x cubed. F prime of x is equal to 3 times 4, that is 12. Subtract 1 to the exponent, so x raised to 2. 3 times 4 is 12. Subtract 1 to the exponent, 3 minus 1, that is 2. So the derivative of f of x is equal to 4x cubed is 12x squared. Another rule in finding the derivative of algebraic function, the sum and difference or difference rule. The derivative of f of x plus g of x is equal to the derivative of f of x plus the derivative of g of x. Okay? So, let's apply that rule. Okay? In finding the derivative of a function, applying the sum or difference, we're going also to apply the derivative of constant rule, power rule, and constant multiple rule. Okay? Example number 9. Y is equal to 3x squared plus 5x. So if we're going to find the derivative of this, so derivative of y is y prime, or dy over dx, is equal to derivative of 3x squared. We're going to apply the constant multiple rule. 2 times 3, that is 6. Subtract 1 to the exponent, so the exponent now will become 1. So 2 minus 1 is 1. Plus derivative of 5x, so just simply remove the x. So the derivative of 5x is 5. So the derivative of this function, 3x squared plus 5x, is 6x plus 5. Another example. Example number 10. Find the derivative of y is equal to 3x raised to 4 minus 6x squared. Okay? So the derivative of y is y prime. Derivative of 3x is raised to 4. So 4 times 3, that is 12. Then subtract 1 to the exponent, that will become 3. Minus 2 times 6, that is 12. Subtract 1 to the exponent, that will become x raised to 1. Okay, so this is the derivative of 3x raised to 4 minus 6x squared, which is 12x cubed minus 12x. Another example, example number 11. F of x is equal to 2x cubed minus 6x plus 9. So f of x, derivative of that is f prime of x. So the derivative of 2x cubed, 3 times 2, that will become 6. Subtract 1 to the exponent, 3 minus 1, that is 2. Minus 6, derivative of 6x, just simply write 6, remove x. Derivative of 9, that's a constant, derivative of constant, which is 0. So the final answer, 6x squared minus 6. So this is the derivative of 2x cubed minus 6x plus 9. And last example for this rule, example number 12. Y is equal to negative 4x cubed plus 2x squared plus 12x minus 8. Just simply take the derivative of each term. So y prime is equal to negative 4 times 3, or 3 times negative 4, that is negative 12, times x, subtract 1 to the exponent, 3 minus 1, which is 2. Next, 2 times 2, that is 4. Then subtract 1 to the exponent, that is x. Plus, derivatives of 12x, just simply remove x. So 12, derivative of negative 8, or that is a constant, derivative of constant, that is 0. So the final answer is this. So the derivative of negative 4x cubed plus 12x squared plus 12x minus 8 is negative 12x squared plus 4x plus 12. So that's the way how are you going to apply the derivative of sum or difference rule. Just simply take the derivative of each term in the algebraic function. Another rule in finding the derivative of algebraic function, which is the product rule. So the derivative of u times v is equal to copy u times the derivatives of v plus copy v times the derivatives of u. So that will be the formula in finding the derivative of product of function. So example number 13. Y is equal to 2x plus 1 times the quantity of x squared plus 3x minus 4. So this will be served as our u, and this is our v. So u here is 2x plus 1, and v is x squared plus 3x minus 4. Okay? So you're going to find the derivative of that, u and v. Okay? So the derivatives of u, derivative of u is 2. Derivative of 2x is 2. Derivatives of 1 is 0. Next, derivatives of v. So the derivatives of v bring down 2, subtract 1 to the exponent, plus derivative of 3x is 3, and the derivative of negative 4 or minus 4 is 0. So this is the derivatives of v, and this is the derivatives of u. And then, we're going to use now this in the formula. Okay? So y prime, so the derivative of y is equal to, copy u, our u is 2x plus 1, times the derivatives of v, so the derivatives of v is 2x plus 3, plus copy v, so this is our v, x squared plus 3x minus 4, times the derivatives of u. So the derivatives of u is 2, so times 2. Then simplify. So in this case, we're going to apply the FOIL method. So this will become 4x squared plus 6x plus 2x plus 3. I just use the FOIL method. So here, distribute 2 to the x squared plus 3x minus 4. So 2 times x squared, we have 2x squared. 2 times 3x, that is 6x. 2 times negative 4, that is negative 8. Then, combine similar terms. 4x squared plus 2x squared, that is 6x squared. 6x plus 2x, that is 8x. 8x plus 6x, that is 14x. Then 3 minus 8, the constant, 3 minus 8, that is negative 5. So this is now the derivative of this function, 2x plus 1 times x squared plus 3x minus 4. The derivative is 6x squared plus 14x minus 5. Another example, example number 14. Y is equal to 6x cubed times the quantity of 4x squared minus 4x plus 1. So we're going to apply product rule here, okay? So our u in this function is the 6x cubed. And v is 4x squared minus 4x plus 1. So our u is 6x cubed. And v is 4x squared minus 4x plus 1. Okay? So we're going to find the derivatives that, okay, derivative of u, okay, the derivatives of u is 18x squared, 3 times 6, that is 18. Subtract 1 to the exponent, x squared. So the derivatives of v, okay, so 2 times 4, that is 8. Subtract 1 to the exponent, so 1 exponent now here, minus 4x, derivatives of 4x is 4, and derivatives of 1 is 0. And then we're going to use now this here. Okay, so the product rule, the derivatives of u times v is equal to copy u times the derivatives of v plus copy v times derivatives of u. Okay, so the derivatives of y is equal to copy u, so this is our u, 6x cubed times the derivatives of v, this is the derivatives of v, 8x minus 4 plus copy v, we have 4x squared minus 4x plus 1 times the derivatives of u is 18x squared times 18x squared. And then simplify. 6x cubed times 8x, we have 48x raised to 4. 6x cubed times 4, that is 24, so minus 24x cubed. Plus, distribute 18 to the quantity, so 18x squared times 4x squared. This is 72x raised to 4. 18x squared times 4x, that will become negative. 4 times 18, 72x cubed Then 18x squared times 1, that is 18x squared. Then simplify, okay? 48x raised to 4 plus 72x raised to 4, that is 120x raised to 4. Next, negative 24x cubed minus 72x squared. So they are both negative, so we're going to add negative 96x cubed. And last, add 18x squared. So we just simply combine the similar terms, okay? So this is now the derivative of 6x cubed times 4x squared minus 4x plus 1 using the product rule. Another rule in finding the derivative of algebraic function, the quotient rule, okay? So the quotient rule is used in finding the derivative of rational function. So the derivatives of u over v. So in finding the derivatives of u over v, just simply copy v times the derivatives of the numerator or the derivatives of u minus copy u, copy the numerator, then find the derivatives of v times the derivatives of v all over v squared. So that's the formula in finding the derivatives of a rational function. Example number 15. Find the derivative of y is equal to x minus 2 over x plus 2. So what is the derivative of this function? So first thing to do, we need to determine our u, which is the numerator, our u, x minus 2. And v is equal to x plus 2. So the denominator. And then find the derivative of this. Derivatives of u is 1. Derivative of x is 1. Derivative of negative 2 is 0. Okay? The derivatives of v is 1 also. Derivatives of 2 is 0. Derivatives of x is 1. Okay? Then, we're going to use now this in the formula. Okay? So, the derivatives of y is copy v x plus 2 times the derivatives of u, which is 1, minus copy u, x minus 2, times the derivatives of v, 1, all over v squared. So our v is x plus 2 squared. Okay? And then, simplify now this. 1 times x plus 2, we have x plus 2. 1 times x minus 2, that is x minus 2. All over x plus 2 squared. So distribute the negative sign, so that will become negative x plus 2. So we have x plus 2 here. And then copy the denominator, x plus 2 squared. Then simplify x minus x, that is 0. And then 2 plus 2, that is 4, over x plus 2 squared. So 4 over x plus 2 quantity squared is the derivatives of x minus 2 over x plus 2. So that's the way how are you going to find the derivative of a rational function applying the quotient rule. The derivatives of u over v is equal to v times the derivatives of u minus u times derivatives of v all over v squared. Another example applying quotient rule. The given rational function is y is equal to 2x over 3x minus 5. So what is the derivative of this? Okay, we're going to apply this rule. But before that, we need to determine the u and the v. So our u here is the numerator. U is 2x. And v is the denominator, 3x minus 5. And then find the derivatives of u. So the derivatives of u is 2. And the derivatives of v is 3. Okay? Over dx, over dx. Next, let's use now this in the formula. So this is our y. So the derivatives of y is y prime is equal to copy v, which is 3x minus 5. 3x minus 5 times the derivatives of u, 2 minus copy u, 2x times the derivatives of v, 3 all over v squared. So our v is 3x minus 5. 3x minus 5 quantity squared. Okay, then distribute. Simplify the numerator. 2 times 3x, that is 6x. 2 times negative 5, that is negative 10. 3 times negative 2x, that is negative 6x. All over 3x minus 5. Quantity squared. Combine similar terms, 6x minus 6x, that is 0. The remaining term, negative 10. Over 3x minus 5 squared. So this is the derivative, negative 10 over 3x minus 5 quantity squared, the derivative of 2x over 3x minus 5.